Yeah, that's it. Go a little bit. Yeah, that's it. I cannot see you clearly.
In the middle.
Yeah, you are in the middle. Yeah.
Third row.
Go ahead.
Okay, go ahead.
Okay, my name is Connie.
And I'm Tommy Anjar.
I'm Philip Dix.
I'm Devin Fowler.
Malik Livingston.
I'm Dan Baker.
Okay, go ahead.
Alright. So for our group project, we kind of wanted to make something that was going to be useful. So I went down to the graduate offices where I work and I walked around asking people like, hey, does anyone need anything built, like a mechanism? And there's a graduate student who sits right across from me who is evaluating the movement of drones in flight while they're taking pictures, so tilt, essentially. They're building a tilt sensor. They need to be able to calibrate it, and they wanted to be able to have a platform that could do 3 distinct rotation angles at 30-degree increments. So I figured, hey, we can do that. Essentially, the inertial measurement unit, the IMU, it has accelerometers, magnetometers, gyroscopes, and it returns a tilt, dynamic tilt estimate of where you're at, but it needs to be calibrated. So really the purpose of this device is to create any possible rotation angle, and then we can know the angle, see what the sensor's returning, calibrate it based on that.
Yeah, I'll start with the socket. So the way he designed it was that it has the 4 prongs so that the ball can fit and easily be rotated around, and then have the silver pieces on the side that can easily go into the slots at the 30-degree increments. And it's just socket to ball and then socket joint, and it's 3-axis rotation.
So the ball has, obviously, it's independent and it's beyond pitch control. There 30 and 45-degree increment options that you can choose from to place the pins in order to do all that calibration. And then simple, repeatable positioning, obviously, with how the holes were drilled and printed.
Yeah.
And then the pins are 15 millimeters.
We sort of had 2 concepts for the sphere. One with radial rows of holes and one with evenly spaced holes in an icosahedron pattern. The icosahedral pattern would allow you to position it regularly in any orientation, but it didn't give you well-defined 2-angle rotations, so we ended up going with this one. And so then we have a mounting plate. Because the ball and socket joint only gives us 2 degrees of freedom and we need 3, we added a more conventional switch here that just has 2 pins and an arc, as you can see. I'll just demonstrate. It rotates. You can see it's got a second hole that you can put a pin in to define those 30-degree angle rotations above the roll axis. And these are 5mm holes instead of 8mm. I ended up having to scale them down to like 4.5 to get them to actually fit. And these parts actually had to be printed, because they're so small, I had to print them out of solid copolyester instead of the PLA I was using for the rest of it. So.
Yep.
Yeah.
Pins. The pins.
The pins. So yeah, the whole assembly, you can rotate discretely, yaw, pitch, and then roll to produce whatever arbitrary coordinate frame rotation matrix you want. It's easy to use, it's easy to, you just print another one. It prints overnight. I don't know exactly how long, because I just woke up and it was done. Yeah, it's a pretty easy to assemble too. Every part just kind of snaps in. Tolerances are pretty good. Anyway, cool video.
That's a nice video.
Yeah, shout out to Devin for making that video.
Oh, okay.
Shout out to SolidWorks for making that video.
Okay.
All right.
Questions? But did you add any like supporting structure when you created the huge ball?
So the ball, it has a flat surface on the bottom.
Oh,
But then
okay.
it needed support structure for each of these holes
Uh-huh.
up to the middle row, and then these top 2 rows didn't need support structure.
Oh,
So
okay.
it just printed upward and it had a little support on the bottom, but not much.
Yeah, great.
I think I saw a
Nice
question.
job.
Did you guys have any of the other designs you were contemplating doing instead?
We talked about doing a clock, I think, but then we thought about the mechanical design of gears and tolerances for that, and we decided that was too complicated.
Yeah,
We had one
I think
thing.
we also just like wanted, like, he talked to some of the grassroots, was like, what can we make that's like, could we put to use? Instead of just making like a, like random thing that's just gonna sit somewhere, we're like, this can actually be used for.
Yeah.
How are they gonna use this?
Are you gonna turn it into the extra pole?
What was that?
Another one?
Are you gonna turn it into the extra pole?
Yeah, maybe
It's
use
not
it.
gonna get used.
Well, the cool thing about 3D printing is that I can turn this in for points, and then I can print another one.
That's true.
So,
And as
That's a
far
tough question.
and as far as for this purpose, we did actually have 2 concepts. I guess when brainstorming, there was another concept that the platform, how it has the hinge and pin. There were some ideas about just an original device similar to that just had 2 sets of hinges that you could just rotate that way, but it's a little bit unwieldy and a little.
it also only offers 2 degrees of freedom.
Right.
So we would have had to add a 3rd joint in
Correct.
line with the other 2, and it would have had to be at a 90 degree to the other 2. So we decided that was prohibitively complex.
Any more questions? Okay, what does it mean?